Hi, as I recently got my Dean Stark apparatus, I want to show you how to dry substances using azeotropic distillation. In this example, I will be drying oxalic acid dihydrate to its anhydrous form. You can also dry other substances, you can also dry liquids, for example ethanol, but oxalic acid is quite hard to get really dry, because when you apply heat to it, it readily sublimes. So azeotropic distillation is probably the most favorable method of drying oxalic acid. We start with 50 grams of oxalic acid dihydrate in a flask. We then add about 200 milliliters of toluene to the flask and set up our Dean Stark apparatus with a reflux condenser. We then start heating our mixture until it starts to boil. As you can see, on the bottom layer, water is collected while the toluene is in the upper organic layer and flows back into the boiling flask. I let this reflux for about 2.5 hours until no more water would collect on the bottom layer. This is a flask after cooling down. As you can see, there's a very thin film of black precipitate, probably carbon, on the wall of the beaker. Normally this shouldn't happen, and even though I used a new batch of oxalic acid, I don't think that this is the reason, because it should be really pure. So my only explanation is the fact that I used redistilled toluene, so probably there were some minor impurities in it that decomposed during the reflux. Then we perform a vacuum filtration to get our oxalic acid. As you can see, when sucked completely dry, it is nearly white, it's very slightly gray, so the impurities aren't that much, it's just a very small amount. And the black spot that you can see in there is my stir bar. There were some other black spots in there, but they were really easy to get out after filtering. But as I said, normally this shouldn't happen when you perform this. As toluene doesn't evaporate that easily at room temperature, and we want to get our product completely free of solvent, we wash it 2 times with 40 milliliters of petroleum ether. Make sure to mix the solid up with the petroleum ether very good, because a lot of times people don't stir around their solid in the filter when washing, which doesn't wash the solid that good. And you can also use other solvents for this. You could also use dichloromethane. The important thing is just that it doesn't dissolve the oxalic acid, but dissolves your toluene and has a low boiling point. After we suck dry our oxalic acid on the pump for a few minutes, we transferred it on a plate and put it in the vacuum desiccator. We then slowly pulled the vacuum to dry it faster, but you could probably also use a normal desiccator, especially when using dichloromethane for the washings, as it's very low boiling. Or you could also probably just heat it on the radiator until it's dry. After we let our oxalic acid dry in the vacuum desiccator for a day, this is our final result. We collected 34.96 grams of oxalic acid, and the theoretical amount would be 35.71 grams, which corresponds to a yield of 98%. This also matches up pretty good with the amount of water that we collected. We collected 13.3 grams of water, and the theoretical amount would be 14.29 grams. So a difference of about 1 gram. But as there's always some loss of water or solvents in general during distillation, this matches up pretty good. And it seems that we got the water out of the oxalic acid pretty good. To prevent that the oxalic acid gets hydrated again, it was vacuum sealed for better storage. I would be happy if you comment your thoughts on this video down below in the comments and give it a thumbs up if you liked it. And if you haven't already, please subscribe to my channel so you don't miss out on my other chemistry project in the future.